Phosphorus-32 is a type of radioisotope, which is a radioactive isotope. Different isotopes of the same element have the same number of protons, but different numbers of neutrons. So put simply, radioisotopes are atoms with unstable numbers of protons and neutrons. All radioisotopes have a different half-life, some longer than others. Half-life is the time taken for atoms in a pure sample of an isotope to decay into another element. It is a measure of the stability of an atom, as atoms with shorter half-lives tend to be less stable. Phosphorus-32 has a half-life of 14.29 days, which is relatively short, and decays into sulfur-32 by beta decay. All radioisotopes produce radiation, whether it is alpha, beta, or gamma. Phosphorus-32 produces beta radiation. It can travel meters in the air and is mildly penetrating to human skin, as it is able to penetrate the germinal layer, where new skin cells are formed. Clothing provides some protection when you are exposed to beta radiation. Phosphorus-32 has many uses, specifically in nuclear medicine, which involves radiation. Many radioisotopes, including phosphorus-32, are used as tracers in nuclear medicine, which are attracted to the area being observed in a scan. Phosphorus-32 can be used in the identification of tumors formed from cancerous cells, as these cells have a tendency to attract more phosphate than regular cells. After the phosphorus-32 has been absorbed, it can be tracked from outside the body to identify the location of possible malignant tumors. The radiation emitted by phosphorus-32 can also be used for therapeutic purposes. It has been explored as a possible chemotherapy treatment for widely spread ovarian cancer, where it is the long-term toxic effects of beta radiation emitted by phosphorus-32 gathering in the cancerous cells that causes the therapeutic effect. It can also be used in the treatment of certain types of leukemia. There are many advantages in the use of phosphorus-32, such as the fact that it emits beta particles that can be tracked from outside the body. This is an advantage as cancerous cells attract phosphate, so the location of the tumor can be traced from outside the body. Phosphorus-32 is also cheaper than phosphorus-33, which makes it more easily attainable. While there are a number of advantages to using phosphorus-32, there are also disadvantages. The beta particles produced by phosphorus-32 are high energy and can cause skin contamination, and also produce low levels of radioactive waste. The short half-life of phosphorus-32 means that it has to be used quickly, as it does not have a very long shelf life. With all these disadvantages, it may be difficult to find justification for the use of phosphorus-32, but as it has the possibility to save human lives through the tracing of beta radiation to discover cancerous tumors, it is undoubtedly worth bearing through the problems to benefit from the advantages.